I think doors are closed. We can probably start. So, who was here last year? A couple of you? Yeah, I was also here last year talking about cloud native development using Orleans. But at that time, I was also playing with preview bits of Aspire, was really excited about it, but unfortunately couldn't talk to any of you about it, but it was then later on made public at .NET Conf in November, I think. So therefore, super happy to be here back today. Finally be able to talk to you about .NET Aspire. Has any of you played with .NET Aspire? A couple of hands, so you know what's it about. Yeah. So yeah, my name is Martin Björkström. I'm an independent software developer, open source enthusiast, and a Microsoft MVP. But before diving into the world of .NET Aspire, let's ask ourselves or look into what's cloud native. Do you have any suggestions? Nothing? Kubernetes, containers? Well, good that there's something called Cloud Native Computing Foundation, and they have an official definition. So let's look at that. It's kind of long and boring. So, but basically, it's about cloud-native technologies. They empower organizations to build scalable applications in modern dynamic environments, yada, 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 both public, private, hybrid clouds. And then we have the container, service meshes, microservices, immutable infrastructure, and declarative APIs. So it's about containers, at least something. But by using these techniques, it enables loosely coupled systems that are resilient, manageable, and observable. And combining this with automation means we can deploy early and often. Right? That's what we want. No more no deploy Fridays. Yes, we want to deploy whenever we want. A wise man once said that we only deploy on days starting with the letter T. Tuesday, Thursday, today, tomorrow. Right. Yeah, so loosely coupled in this sense is what we always do. We depend on infrastructure, contracts, rather than implementation details, being it RESTful APIs, RPC, messaging, or whatever. But our systems, when they talk to each other, they depend on contracts. And our services also resilient. Resiliency in this sense means that when we run something in the cloud, shit will happen. Something will go down, and something will not, we will not be able to communicate with it, and 95% of the cases, it's DNS. So therefore, our services need to be fault tolerant. We need to be able to recover from problems. For example, we need to have retries, idempotency, and so forth and so forth. I think Mike Martin will talk to you tomorrow about failure. It was something called failure is not an option or something like that. If you want to know more about resiliency, go check that out. And manageable, in this case, should be possible to sufficiently alter system behavior without altering or building new versions of this application. For example, a lot of things need to be configurable. One thing that we want to do when we deploy our application is, for example, we build once, and then we take that artifact and then we promote it to different environments, such as dev, staging, prod, and so forth. So no rocket science here. And then observable, meaning that without having to know that much about our system or without having to rebuild our system, we should be able to ask questions about the system, know what's happening underneath. So And we usually talk about something called open telemetry. And so we get something like traces and metrics. So we get to know what's happening underneath. And then we have distributed systems who want to have something called distributed traces. So that when we do a call from one service to another through our system, we see how these messages propagates throughout our system. So that was slightly about cloud native and what we try to solve with cloud native. So next thing that we do then, we go to Cloud Native Computing Foundation. They have a thing called Cloud Native Landscape, which shows all the projects that's there. This is an old picture. See what the problem is with this picture? Can you see anything? I can't see anything. So one of the problem is here, of course, you can't use all of this in your application. Is someone here using all of this? No, hope not. Yeah, so there are so many services, and when you connect to these, you want to configure resiliency, all that kind of stuff, open telemetry to get traces, metrics, and all that stuff. So this was something that the .NET team noticed when they were helping internal teams at Microsoft, and they weren't using all of these, mostly probably Azure services and stuff like that. But they noticed that there were lots of code written over and over again for using these services with regards to resiliency, observability, etc., etc. So they created some internal library, which later evolved into parts of what we today know as Spire. So to tame the beast, that is cloud native development. They released at .NET Conf last year, .NET Aspire. It contains of 3 parts mainly we talk about. The first one, and where it really shines, is the orchestration part. Because .NET Aspire, it provides features for running and connecting multi-project applications and their dependencies, be it containers, executables, or Azure services, AWS services, and so forth and so forth. This is kind of evolution of a tool called Thai. Have any one of you used Thai? 1 hand, 2 hands. So Thai was this Docker Compose on steroids. It was YAML-based, where you defined your .NET projects and then your containers, and then you pressed F5 and you got everything up and running. The evolution of this is now that they skipped YAML, and you can do this kind of orchestration in C#, and it's not only limited to containers. You can also connect Azure services or executables, whatever, and it's very easy to extend, so you can do whatever you want because it's in C#. We'll look into that later. Second part, integrations, previously known as components. They changed the name in the last version. So .NET Aspire integrations, they are just NuGet packages for commonly used services, such as Redis, Postgres, and Azure services, whatever. Probably what you want to use, it's there. So, and they have these standardized configuration patterns for adding health checks, adding telemetry, and all that stuff. And the integrations, they come in 2 parts. One part is the hosting package, which connects into the orchestrator for spinning up that service or connecting or creating that service. And then the other part is the client, which goes into your application for then communicating with that service. And as I said, they changed the name from components to integration because components, that's like a widely used term. For example, if you ever have any of you used Dapper, Distributed Application Runtime? Couple of hands, yeah. You know, in Dapper, there's a thing called components. What components there do, they abstract the underlying services. So you have like this, always the same kind of API, regardless what kind of the underlying service is. But Aspire doesn't try to do that. If you work against a key vault, you use the Azure SDK, for example. So it's only a matter of configuring these or spinning it up and configuring with regards to resiliency, observability, etc., etc., etc. And then last part, tooling, because we have Visual Studio and all that stuff. So there's some project templates and it plugs nicely into Visual Studio Code, .NET CLI, also third-party plugins, for example, for JetBrains Rider. And also help with integration testing your Aspire solutions. So all these kind of nice thingies. That was basically the slides that I had. So I think it's easiest if we just go through some code and check what's it all about, right? Let's see. So what I have done here this is Rider, by the way. What I've done here is I've done a new Aspire starter application, which basically give us 4 kind of projects. It gives us 4 projects. And the first project that we have here is the API service. And this is basically what you get when you do a .NET new web API. It's a minimal API that will return some weather forecasts for you. Nothing fancy, but it's there. And this web application here, it's same as you get when you do .NET new web. You know, the Blazor web, where you have the counter on one page, and then you have one page showing weather information. You have all seen these applications probably, yes. So, and then we have 2 Aspire-specific projects here. And what these basically do here, or what this sample does, is that because this web application will show some weather information and this API service will provide the weather information. So this basically, it's 2 services talking to each other. That was a nice needle, yeah. So, and before Aspire, if we wanted to do this, just having multiple starter projects was a pain, right? Could be. My colleague used Visual Studio, there's one way to do it. And then I use Rider, there's one way to do it. And then probably a third colleague using just Vim and .NET CLI, so there's another way to do it. And then we need to copy over the endpoints for which this API services is listening to and add it to the configuration for the web application. And then some of these ports work on my machine, but not on my colleague's machine. And it's kind of a mess, or was kind of problematic, if you want to run multiple projects. Also, debugging could be problematic. But Aspire then provides us with 2 new projects. First project here is the app host. And this is the entry point in all Aspire solutions, so to say. This is where we define what are our services, what are their dependencies, and how do they communicate with each other. This is what we do in C# today. And it's real nice once we go to look at it. And then there's another project here. It's a class library called service defaults. This is basically just extension methods which are provided to you. They set up open telemetry, health checks, and all that kind of stuff. And it's free for you to just go and modify them to your need. But you get a starting point, and then you can modify it just the way you want to have it. So, if I now press F5, let's look what happens. Oh, can everybody see the dashboard? Yes. So, in our Aspire project, I had the app host as my startup project. And I had the 2 services. So what we get here, we get first a nice dashboard, which will show all our projects. We had the API service, we have the web front end. I can see the endpoints, what they provide, and I can see some logs. I can see some details about it, for example, what are the environment variables and so forth. I can then click also this endpoint. I see you probably know this application, the counter, and then the weather. Can refresh the weather. And if you go back to this web application here, not web application, the app host, of course, app host, and how this is then configured. So in our Aspire app host, that project has a project reference on all our services. So we get kind of this IntelliSense. We got some code generation. So we can easily detect or add our projects. So what we do here is we create a distributed application builder, and this will use the same builder pattern that you are familiar with from ASP.NET Core and so forth. And then on our builder, we say that, hey, add this project, the API service, and give it a name, call it API service. And then we add another project, the web front end, and this is mainly for deployment. We'll look into this later. But then also we add a reference to this API service in the web front end. And what this will do is that it will inject the endpoint of this, you see, 551. It will inject the endpoints of the API service into this web front end, so that our web front end, the weather API client, which will communicate with this, we can just say that, hey, we want to connect to the API service, and can see that it also works. If I go here into the weather API client, I'll add a breakpoint here, and I go to the API service, to the minimal API. We have the weather forecast at a breakpoint here. I think that this, let's see if it works, but I think Ryder complained about modified sources, so let's see if it works. But if I press F5 here, it goes to the weather API client, and then press F5 again, it goes to the API service. So debugging multiple services is fairly simple. Just one entry point, and then we can debug all the services. Let's remove these breakpoints. Yes. And if you remember here, like you saw, we had this. We call it API service here. Nothing more, nothing less. And if I open up my terminal and I just try to ask DNS about API service, can't find it. But how does the web front end know about a service called API service? Well, like you remember, we had this project called the service defaults, which was some extension methods. And here in our web application, on the top of it, we do something called builder add service defaults. If I go into this, I can see that, hey, it configures OpenTelemetry, which we'll look into shortly. It adds some health checks. It also adds service discovery and configures our HTTP clients for service discovery, meaning that based on some conventions, our web front end will find the API service. And when running locally, for example, here, as we saw, we had environment variable. Aspire injected the endpoint of the API service into our web front end. So then the service discovery knows where to find API service. And if running on Kubernetes, for example, we can ask Kubernetes DNS service where to find it. But this is kind of stuff that simplifies things, and you don't need to worry about it. Aspire takes care of that. All the endpoints are injected as environment variables, and everything should just work if you set it up correctly. So we also saw that we had some traces, open telemetry. So when I hit this, press F5, press F5 again, I can go here into the traces. I can see that when I hit the weather endpoint, I click this up, I can see, okay, we hit the weather endpoint, it's a GET operation, and it will also call the API service. And then I think when I hit it again here, I see that it only called the web front end. And do you know why? Caching, yes, caching. Because I know that in this weather page, there is caching. There's output caching for 5 seconds. So if I hit F5 rapidly, during 5 seconds, it will use the cached version. Now, in a distributed environment, what is wrong with this caching that we have here? Or might be wrong. So, the caching that we use here, in this example now, it's using in-memory cache. So it's only available on that instance. If we run multiple instances, we probably want distributed caching, right? Because otherwise, all of our instances will have separate versions of the cache. So when I hit something, I see it. When I press F5, I get from some other place. So we probably want to add a distributed cache. What service do we usually use when we want to use a distributed cache? Redis? Redis, yeah, it's great key value storage for caching. So, if I now want to add Redis to my Aspire application, how do I do? You remember integrations, right? So, in my app host, which do add a NuGet package, and then I'll search, it was already searched for, I'll search for Aspire hosting. All the packages starting with hosting, they are for your app host, for spinning up these services, provisioning these services, creating. So Aspire hosting and then Redis. I'll add this to my app host project. Add and install. And it's installed. And then I want to use the Redis as a output cache in my web application. So what I then do, for the other part of the integration, I'll install it on my web application, manage NuGet packages, and I think it's using the Stack Exchange version of the Redis, so Aspire Stack Exchange Redis, and output caching. Install that. My web application, and it says it's installed. So if I want to spin up a Redis here, I go back to my app host where I configure all my services, and I do just var Redis builder add Redis. Give it a name, call it Redis. And then I need to tell Aspire that our web front end has a reference on Redis. So do with reference Redis. I'll save this. So hopefully these 2 lines of code will add a Redis container and inject information about how to connect to that Redis into our web front end. Hopefully. And then we want to use it in our web application. I go here. I installed the package, you remember the Aspire Stack Exchange Redis output caching. So here, the builder services output cache, just remove this, and then we do builder add Redis output cache. And then we need to give a connection name. I think, did we call it Redis in the app host? We called it Redis, right? Redis, yes, Redis. And then we need to use the same name in our output cache, Redis. So now, if I press F5, hopefully we'll get a Redis up and running and working. Let's see. Boom. Now, on our dashboard, we see a new resource type of container. Got the name Redis. We can see the source, what kind of Docker image it's using, and we can see the endpoint it provides. And also, hopefully, if I check here in the environment variables for the web front end, I can hopefully see that we also have a connection string Redis configured. And it's the same port that our Redis is listening to. So now, if I go to my web application, click weather, and press F5 again, then F5, then wait, and then F5, you can see it refreshed. Now, let's go back to our dashboard, inspect our traces, and see, did it really use Redis? So here, get weather. This one also used the API service. Click this. You can see, yes, it did. Also got a lot of. But yeah, we hit the weather endpoint. Web front end tried to communicate with Redis. It didn't find it. It didn't find the cached or anything about the output cache in Redis. So it called the API service, and then it stored the data in Redis. And then when I hit it again, I can see that the data is served directly from Redis. So with these 2 lines of code, we got a Redis container up and running. We connected to the Redis container. We got OpenTelemetry configured. So we can see the traces, how these services communicate with each other. It's kind of neat. And we also got something called health checks. Are you familiar with health checks in ASP.NET Core? You have used health checks? Yeah. So yes, in ASP.NET Core is a nice health check API, which you can use to add kind of this, so you can see how your system is feeling if you can connect to all of these dependencies that they have. So it's kind of nice. And what Aspire now did when I did add Redis output cache, it hopefully added a health check for our Redis. And if I call the health check endpoint, I can see that we have something here called in our health check output. I can see that, yeah, Stack Exchange Redis, and it's healthy. But then if I go and shut down the Redis container through Docker Desktop, and then again run this, I can see, okay, Stack Exchange Redis, it's unhealthy. And I can go back to my dashboard, can see the resource, I can see the Aspire can't connect to our Redis container, says it's exited, and hopefully my weather application still works. It's just a little bit slow. Yeah, it works, but it's a little slow because it can't connect to Redis. And now I just start it again. I can hopefully see that our health check is now healthy. So, 2 lines of code. We got Redis up and running, we connected to it, we got OpenTelemetry configured, we got health checks. Are you impressed? 2 lines of code. And thanks Sophia afterwards. Yeah, so 2 lines of code. Not that much. Very easy to integrate with. So I think that in the abstract we also talked about deployment. So just stop these services. And what Aspire also does, if we go and look at this app host here, and close these so we can see anything. So this, where we define our services, all the dependencies, and how they connect with each other. So what Aspire then can do when it comes to deployment is that Aspire will or can generate a JSON manifest which will describe what are our services, how they connect to each other, and so forth and so forth. And then third-party tooling can read that manifest and create resources, for example, in Azure for us, or in AWS, or there's also third-party tooling for generating Kubernetes manifests when it comes to deployment. And so let's just look quickly how this kind of manifest looks like, app host, and then I can run this manifest, generate this manifest. And then let's look at it. Look at our manifest. So it's just JSON. It says, hey, we have the API service, this is the project, and these are some of the ports. And then we have the Redis container, web frontend. So if you remember, those of you who had used .NET TIE, you remember that .NET TIE also did deployment, but it was something that TIE did by itself. So TIE could deploy to Kubernetes, for example. And what .NET team did in Aspire, which I think is good, that they removed all the deployment stuff and just generate a manifest. So the third-party tooling that does deployment better can do it just the way they want. Right. So let's look into how, for example, any of you used Azure Developer CLI, AZD? Yeah, let's look into how that can use this manifest to generate or deploy our solution to Azure. So just what I need to do is just I'll take AZD and initialize, and that is my subscription ID in Azure. And then it will ask something that, hey, where's the code? I say use the code in the current directory. It will search my directory for something. It found a .NET Aspire project or solution, the app host. I say, okay, this is good. I want to do here. Here it asks for a name, so let's call it Sweetag GBG, and it generates some documentation for us how to proceed. So now, if I want to deploy this to Azure, all I need to do is do AZD up, and it will deploy it to Azure. But I can also, AZD has this kind of thing where I can synthesize or generate the infrastructure, the bicep files, which will be used. So I can do AZD infrasynt, and we can look at some of these bicep files. Any of you used bicep for Azure? Yes, most of you. Okay, so I can look here, and I'll just go code infra. You can see some of these bicep files. We have a main bicep file. Is this enough? We have creates a resource group, and then we have the resources here, creates a managed identity container registry, and all the stuff we need basically to deploy our solution to Azure Container Apps. Any of you use Azure Container Apps? A couple of you, yeah, so you know. So what I then can do is just go back here and then do AZD up, but this will take some time, and as all chefs on TV, I've prepared something for you. So I have here, I have a resource group which was deployed using AZD up on this same solution. So what it created for us, it created a container registry, container app environment, and our container apps, and then log analytics workspace and the managed identity. So we get logs, and we can pull the Docker containers from our container registry. I can click here on the container apps environment, and container apps nowadays integrate very nicely with .NET Aspire, so I also get the nice .NET Aspire dashboard for free. So I can just click here and then open dashboard, and this is secured using Entra ID. So only I can access this dashboard, and I can see the same services here, but they're now running in Azure. So remember, we have the API service, we have the Redis, we had web frontend. I can open up this web frontend. I can hopefully go here and click these. I can click the weather, can press F5, and then I can go back to the dashboard, see the traces. I can see that this one, for example, I can see that, yeah, when we hit the weather endpoint, it went through to the Redis cache, and then it called the API service and then stored the data in Redis. So this is kind of a easy way to get your application just for testing purposes up to Azure if you want. And then you can take these bicep files or whatever, you can take it as a starting point for your CI/CD pipeline, which is kind of neat. So you get a starting point for your infrastructure as code. Right. That was the deployment part. Now, one more thing here. Any of you using Azure? Lots of you using Azure. Okay, any of you using Azure Service Bus? Do you think it's a pain, local development with Azure Service Bus? Not. Some of you think. How do you solve it? There's no emulator or anything with it. Do you have a shared service bus, or does everybody deploy their own service bus, or some have shared, some use their own. But as I said, .NET Aspire isn't only about containers. You can also, I use Azure, so I will show Azure, but there's also this, you can also do this, for example, with AWS if you want. There are third-party solutions for it. If I want to add some Azure services to my Aspire application, what I can do then, of course, at first, I need to install some NuGet packages. And we probably remember that all the hosting packages for our app host, they start with Aspire hosting, and then all Azure packages, Aspire hosting Azure. So we can add storage. Storage is nice. And then service bus, it's something that we probably also want. Yes, let's install that to our app host. Then, once we have these packages installed, here. So if we want to add a service bus now to our application, or Azure storage, what we can do first with the service bus and builder, add Azure service bus. We'll give it a name, just call it Service Bus 1. And then we'll probably want to add some queues. Q1, we add some topics, add topic. Because naming is hard, we'll call it topic 1. And what we will call the subscriptions? Subscription 1 and subscription 2, yes. So now we hopefully added an Azure Service Bus. Let's also add a var storage, then builder, add Azure storage, call it storage. Then on our storage, let's just blobs, and then add a storage and use the blob endpoint blobs, and we call that blobs. And then on our web front end, we'll add reference to both the service bus. What did I call it? SB, just, okay, SB. And then with reference blobs. So now, hopefully, when I press F5, I will get an Azure Service Bus and an Azure Storage provisioned for me. And connection strings, or how to connect to this, will be injected into my application. I can see here the dashboard. Okay, we have 3 new types. We have Azure Blob Storage Resource, Service Bus Resource, Storage Resource. I can see some of the state, what it's doing. So it was creating some ARM templates, and now it's waiting for deployment. I can probably also go here to Azure, to my Azure, and look at the resource group which I've configured to use. Look at the deployments here. I can see that something is happening. We have some storage deployment, and we have a service bus deployment. So go back to my dashboard. Just wait a little bit. It's deploying. It's waiting for deployment. Oh, now it's up and running. And you can see here, go here, you can see the endpoints, so we can see the deployment. I can just click on this, it will take me to Azure portal. You can see the service bus, go to the resource group. We had it called SB1, I think. And hopefully we'll see the queue. We created a Q1, and then we created a topic. It's here, everything is here. And then information about how to connect to this service bus or Azure Storage was hopefully injected into our web application as connection strings. And these connection strings will by default use managed identity, so there's no secrets here. That's just using your credentials to connect to these. So with these two lines of code, we got Azure resources provisioned for us just by having it here and pressing F5. It provisioned everything for us, which was kind of neat, right? Right? Yes, yes. Imagine like when you onboard new developers and they clone the repository and they have a Word document containing of 20 pages on how to set up the environment, instead of just cloning the repository, pressing F5, and .NET Aspire will create your local environment for you. Imagine the time you'll save with these kind of things. So this is, if you remember in the beginning, I said that Aspire, the orchestration part, this is where it really shines for local development. And this is where it really helps. So you can connect multi-project applications. You just define their dependencies and how they connect to each other. Will spin up containers for you. It can create Azure resources for you. Also, you can connect it to AWS, so it will create everything for you there also if you want. And as for example, when it comes to Azure Storage, Azure Storage, it has a good emulator called Azurite. You can just here use run as emulator, and now if I press F5, I can see that hopefully that it will use Docker container for this Azure storage instead, yes, it will use the Azurite Docker container, use that instead of Azure resource. And now you also saw that this service bus, it doesn't go and provision a new service bus for me every time I press F5, because that would be ridiculous. It will take too much time. So there's state behind this, so it knows, or naming conventions, so it knows where it will find your service bus, and because it finds my service bus, it doesn't try to provision it again. It just connects to it and then injects information about it to my application. So that we are slowly running out of time. So let's just stop here. Stop this here, and I can also see if I go into my app host, and then if I want to generate the manifest again, and look at the manifest again, you can see we have some more. We probably got the Azure storage here, and we also got the service bus here. And what is nice here, if I look here in the app host, or the Aspire app host project, when we create, even though we say that run this storage as an emulator, when we deploy it, it will deploy a Azure storage or to Azure with Azure Developer CLI. And also I could probably also do, if I want to, just because this is C# and it's easy to extend, I can do that when for local development I want to use a Redis container, but when I deploy it to Azure, I want to use Azure Redis service and not deploy it as a container, for example. So all of this is kind of simple to use, and it's very easy to also write your own extension if there's something you think that's missing, or just adding custom containers. You don't just, what this does behind the scenes is just using some of the APIs to add a Redis container, but there are shorthand methods for this, like add Redis. But it's very easy to add your own containers if you want, if it's not part of this. So that was basically all I had about .NET Aspire and the demo I had. So if you want to get started with Aspire today, you can go just to GitHub. Everything's open source, most of it. Go there, start playing with it, and it requires .NET 8, not that much more, so it's very easy to use. And if you have any questions, come talk to me. I'm here all day, or reach out via social media. And I think that was about it. Thank you.